Okay. Um, this is probably going to be only you that missed a lot on the Unit 4 Skill Assessment 2. So I'm going to be working through this test. The retest is different. Corrections will not be allowed for a retest. You will be taking the entire retest. So first we're looking at if something's a polynomial or not. And write it in standard form. State the degree and the leading coefficient. So whether it's a polynomial or not is really based on the exponent of x. So this is really x to the 1, x to the 5th, x squared. This would be an x to the 0. All of the exponents have to be whole numbers. So they can't be negative, they can't be fractions, they can't be anything weird. So we're good. So standard form means to take the biggest exponent and write it first, and then go down from there. The degree is the largest exponent, so the 5. The leading coefficient is the coefficient of the very first term. The next one, the exponents, x to the 4th, x to the 1, this would be x to the 0, and x cubed. We're good. This is a polynomial. So I write them in descending order. The degree is the largest exponent. The leading coefficient is the one that comes first. Next one, looking just at the exponents. This would be like having an x to the 0, x to the 1, x to the 7th, and x to the 5th. I'm okay. A lot of people thought it wasn't because of this coefficient. Being a polynomial or not has nothing to do with the coefficients, but everything to do with your exponents. This is a degree of 7 with a leading coefficient of 30. Now this one, on the other hand, x is in the exponent. That means it's unknown. We don't know what it is. It could be anything. It could be negative. It could be anything. So x cannot be in the exponent. It is not a polynomial. Okay, in behavior, let's think about some things. I'm going to come off to the side here. If I have an even exponent, think like x squared, and it's positive to start with, it's always going to go up and up. If it's negative, it's going to go down and down. If I have an odd exponent, let's think of a linear function. Linear function with a positive slope. Let's start at the bottom and go up. A negative slope. Let's start at the top and go down. So all we have to do is look at is our degree even or odd, and is our leading coefficient positive or negative. So in this one, I'm odd for the degree and negative for the coefficient. That means I'm going to start up there and go down. So let's talk about the correct notation for in behavior. We have the right side of the graph. On the right side of the graph, we're thinking about x's that are positive. So we say as x goes to positive infinity. We want to know what our function or our y values do. On the left side, we're looking at negative x values. So what happens when x gets more and more negative? What is our function doing? So let's look at this graph. On the right side of the graph, it's going down, 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 down. It's going to keep going down and down and down forever until it reaches negative infinity. On the left side of the graph, it's going up and up and up and up. So it would go to positive infinity. This next one is even. and it has a positive coefficient. It's going to go down. Oops, no it's not. Goes up and up, doesn't it? Positive. Happy face. Opens up and up. So both the right side and the left side are going to be going to the same direction. They're both going positive. Now another way you could figure out what's going to happen is by plugging in big positive numbers or big negative numbers and seeing if the number you get back is negative or positive. But if you can learn the degree and that leading coefficient and follow these little rules, it gets super fast. The next part, skill set B, polynomial operations. These first ones, we're just adding them together. So, since it's just addition, I'm going to look for any like terms. I don't see any other 8x to the fourth. I don't see any other x squared. I don't see any other x's. And I don't see any other constants. If you're subtracting, then we have to distribute that negative through that second set of parentheses. That's the easiest way to do those. So that would be negative 3, subtracting an x squared, and subtracting a 2x. Now I'll see if I have any like terms. That's x to the 7th, so there's no other x to the 7th. There's no other x squared. That's a 14x and a negative 2x. That's going to give me 12x. And then the negative 3 would be at the end. This one is also subtraction. So I'm subtracting 9x squared, subtracting a 3x, and then be careful here, I am subtracting a negative 13, so it's going to be like adding a 13. Again, look for your like terms. We've got 11x squared and negative 9x squared, that's 2x squared. Negative 6x and a negative 9x, 3x gives me a negative 9x. Then I have a 2 and a 13. The next one is multiplication, and you can do this one of two ways. You can just distribute, or if you like to be more visual, you can make a multiplication box. Either way is fine. I'm going to do the distributing way. I'm going to take x squared and distribute it to each of those terms. So x squared times 10x to the 4th gives me 10x to the 6th. X squared times negative 8x cubed gives me a negative 8x to the 5th. X squared times 2x is 2x cubed. X squared times negative 6 is negative 6x squared. Now I'm going to distribute again, but with the negative 4. Negative 4 times 10x to the 4th gives me negative 40x to the 4th. Negative 4 times negative 8x cubed is going to give me a positive 32x cubed. Negative 4 times 2x is going to give me a negative 8x. And then negative 4 times negative 6 is going to give me a positive 24. Now this is an okay answer, but it's not the best. We were talking about standard form. It is always better to write your answer in descending order and looking for any like terms, like here. 2x cubed and 32x cubed give me a 34x cubed. There's no other like terms, so I'm just rocking and rolling through the rest of it. One of the highly missed problems, long division. I'm dividing by this, so it goes on the outside. And I'm dividing into this, but notice that we're missing some terms. Normally, if I started off with x to the fourth, the next term would be x cubed. The next term would be x squared. The next term would be an x, and then I would have a constant. If you don't put in those placeholders, that can really mess you up. Now, in long division, I'm taking this first term here and this first term here. What do I multiply x squared by to get 2x to the fourth back? Well, I would need a 2 and an x squared. Notice how I lined that up on top of the x squared. When I multiply, I get 2x to the fourth. 2x squared times x squared is x to the fourth. 4x times 2x squared is going to give me 8x cubed. Notice that they line up. You want that to happen. 2x squared times 4 is 8x squared. The next step is to subtract. Same as long division has always been. So I would subtract all those terms. 2x to the fourth minus 2x to the fourth goes away, as it should. 0 minus 8 is going to give me a negative 8x cubed. 0 minus 8 gives me a negative 8x squared. Bring down the next term. Now, this is my new first term compared with this. What do I need to multiply x squared by to get negative 8x cubed? Well, I know I need a negative 8 and another x. Negative 8x times x squared is negative 8x cubed. Negative 8x times 4x is negative 32x squared. A lot of people told me it was 12. 4 times negative 8x is negative 32x. Again, long division of old, we're going to subtract, so you have to be awfully careful here. A negative 8 minus a negative 8 goes away. Negative 8 minus a negative 32 is like having negative 8 plus 32. That's going to give me a 24x squared. 0 minus 32x is going to give me a positive 32x. Bring down the next term. What do I need to multiply x squared by to get 24x squared? Well, that would be a 24. 24 times 4x. Now, I'm even going to be lazy. I don't know that off the top of my head. 24 times 4 is 96. And then 24 times 4 is 96. So, like in the olden days, we're going to subtract. 24 minus 24 goes away. 32 minus 96 gives me negative 64x. 0 minus 96 is a negative 96. This is considered the remainder. So what we usually do is write as a fraction above what we divided by. And we're good. This would be our solution. That is our quotient plus the remainder over what we divided by. Number 12, synthetic division. Synthetic division can only be done if you have x plus 1 or x minus 1 or x plus something, x minus something. On the outside of the synthetic division box, we put the solution to what we would divide by. So in other words, what would make x plus 1 equal 0? Well, that would be the number negative 1. Now we list our coefficients, making sure that if I miss anything, I put a 0 in its place. So x to the fourth, x cubed, x squared, x, and the constant. Underneath the constant, is going to be my remainder. So when we're doing synthetic division, you bring down the first term, you multiply to go up. And when I say multiply, I'm going to take that number and multiply it with the one that's on the outside. So that's why it's very important to have the right number on the outside. So that gives me a negative 10. Add down, negative 23. Multiply up. Negative 23 times a negative 1 is going to be a positive 23. Add down. Multiply up. Add down. Multiply up. Add down. That's my remainder. Now, we started off with an x to the fourth. We divided by an x, so I'm going to be starting with an x cubed. And the remainder is always written over what we divided by. Now, this one I can use either method. Synthetic is faster. You can use either one, but either way you do it, notice it's missing an x squared. So whichever technique you do, like I'm going to do synthetic, you're missing an x squared. If you don't put that 0 there, you won't get the right answer. 4 comes down. 4 times 4 is 16. Add. Multiply. Add. Multiply. Add. Multiply and add. So remember, we started with an x to the fourth. So this one's going to be 4x cubed, 14x squared, 56x, plus 220. The 895 is the remainder over what we divided by. Factoring. Factoring, if you have something in common, you want to factor that out first. So not all of them have x's. There's 24. No, they don't all have the same numbers. So I would try to factor maybe with the box. It's a great idea. There's 4 terms, and there's 4 spots in the box. Remember, this is actually factoring by grouping. It is actually an okay method. If we look across that first row, they both are divisible by 4, and they both have at least x squared. 4x squared times what gives me 20x cubed? That would be a 5x. 4x squared times negative 1 gives me a negative 4x cubed. Now all I'm missing is a 3 over here. 3 times 5x is 15x, and 3 times negative 1 is negative 3. These are my factors. 4x squared plus 3, which means I know it's not going to factor, and 5x minus 1. Since that's linear, it's not going to factor anymore either. I'm done. Now in 15, there were 2 ways to approach it. If you notice that they both had an 8 in it first, it actually made it a lot easier. That'd be 8x cubed plus 8. Now, x cubed plus 8 matches a special pattern. That special pattern is something cubed plus something cubed factors into a special pattern. I put a plus b, and then a squared minus ab plus b squared. So x is going to go wherever an a is. What cubed gives me 8? Well, that would be a 2. Now, the 8 over here stays on the outside. In this first parenthesis, what is being cubed first? It's an x. What's being cubed here? It's a 2. Now, all I have to do is look back at the first parenthesis. Whatever that is, squared. well, that's x squared, minus the two of them together, plus this last one squared. And this one never factors anymore, so you're done. Now, this one, really crazy, but actually quite easy. Since there's nothing in front of that first one, we can actually do it from here. What's going to multiply together to give me x to the fourth? What's going to multiply together to give me a negative 32, but add to be a negative 4? That would be 8 and 4, right? Have to be a negative 8 and a positive 4. Neither of these are difference of squares, so we're done. You could have also used the box method on that one. Finding the zeros by factoring means you have to factor first. One thing that's nice is that these actually have a greatest common factor. These are all divisible by 3, and they all have an x in them. So that would leave me with x squared minus 2x minus 15. Ooh, since it doesn't have anything in front of x squared, that makes it so much easier to factor. The only possibilities are x and x. These two have to multiply to be negative 15 and add to be a negative 2. So negative 5 and plus 3. Now, when we're finding the zeros, we're finding what makes that equal 0. So we have to set each factor equal to 0, including that one. What's going to make 3x equal 0? Well, when x is 0. What's going to make x minus 5 equal 0? Well, that would be 5. What's going to make x plus 3 equal 0? That would be negative 3. On number 18, it also has something in common. Ooh, let's take out a negative 2 and an x. That would leave me with x squared for the first term, a negative 12x for the next one, and a positive 32 on the last. So here's a negative 2x. It's got to be an x and an x, positive 32, and add to be a negative 12. It's got to be a negative 8 and a negative 4. Set each factor equal to 0. Well, this is going to give me x equals 0, x equals 8, and x equals 4. Now, this last one was a little bit tricky. It is following that special pattern of the difference of cubes. That factors into a minus b times a squared plus ab plus b squared. So what is being squared first? That's an x. What is being squared next? That's a 2. So I end up with x minus 2, a squared, so that's going to be x squared, plus the two of them together, plus b squared. The first one's easy to do. The second one, not so much. You have two ways to do that. You can either use the quadratic formula, or you can do completing the square. I'm going to do the quadratic formula. X equals negative b plus or minus square root of b squared, that'd be a 2, minus 4 times a times c, all over 2 times a. That's going to give me a 16. So 4 minus 16 is going to give me a negative 12. That's going to give me 2i root 3. Oh, they're both divisible by 2. That would give me a negative 1 plus or minus I root 3. That one was the hardest one. Now, the next problem. Write a polynomial function from these roots. In other words, work backwards. If I know the solution, what's going to be the factor? So x equals negative 2 is going to give me x plus 2, because the x plus 2 equals 0 gives me that. Now this one's a little bit harder. If I have x equals 3i, a way to get rid of that I is to square both sides. X squared equals 9i squared. But what is I squared? Well, that was a negative 9, right? Because if you took the square root of negative 9, that would give you a 3i. So x squared plus 9 equals 0. If it had been 2i, I would have gotten x squared plus 4. If it had been 5i, it would have been x squared plus 25. So think about how you can work backwards to solve those equations. So x equals 1 would mean I'd have x minus 1. Negative 1 would have been x plus 1. This one is a lot trickier. And we went over one of those in our review day to help prepare you for the embedded assessments. X equals 1 plus 2i. Now, it was really nice when I had 3i by itself because I could just square both sides. So I'm going to move the 1 over and get x minus 1 equals 2i. When I square both sides, I get x minus 1 squared equals 4i squared. This is where everybody messes up. That's really x minus 1 times x minus 1. So x squared minus 2x plus 1 equals negative 4, because I squared is really a negative 1. Now I'm going to get everything on one side and set it equal to 0. Why? Because when we're solving for roots, we take that and set it equal to 0 as our first step. So when we're working backwards, it's going to be our last step. Now, the next one, graphs. This has zeros at 1, negative 6, negative 1, and a positive 8. None of those are repeats because none of them are squared. If I multiplied this out, it'd be x times x times x times x. So it's an x to the 4th, which means it kind of looks like a parabola, which means the graph is going to do something like that. The next one, we have roots of 2, negative 3, and 6. The difference is these are what we call doubles. Your graph is going to bounce at those. And this would be x squared, and an x. This is going to be an x to the 5th. So it starts at the bottom and it does something and goes up. 2, negative 3, and 6. So each time it comes up to when one of the factors are squared, it's going to bounce. Bounce, bounce, and go through. I wasn't concerned with you being exact. What I was concerned with is going through those roots. Very last one. I actually expected you to do a little bit of a trickery on this one. If you worked backwards on this one, you could find some of your roots using the calculator. 6x to the 4th minus 7x cubed minus 13x squared plus 4x plus 4. If I look at my table, I can actually find some of my roots. Negative 1 and 2. I can also see my y-intercept, so I'm going to go ahead and mark that on my graph. 0, 4 is my y-intercept. One of my zeros was negative 1, and one of them was x equals 2. That means two of my factors are x plus 1 and x minus 2. If this is an x to the fourth, I should have 4 zeros. So what I'm going to do is divide by each of these. Now when I'm dividing using maybe synthetic, I'm actually using the solutions on the outside for synthetic division. So first I'm going to divide by x plus 1, which means I'm going to put the negative 1 on the outside. The 6 comes down. 6 times negative 1 is negative 6. When I add down, I get a negative 13. Negative 13 times negative 1 is a positive 13. When I add down, I get a 0. 0 times negative 1 is 0. 4 plus 0 is 4. When I multiply, I get a negative 4 and a remainder of 0 as well I should. Now I'm going to divide by the 2. Kind of like those when we were doing factor trees. You can just keep going. 6 comes down. 6 times 2 is 12. Get a negative 1, negative 2, negative 2, negative 4, and a 0. So now, it was x to the fourth. When I divided, I got x cubed. This is going to be x squared minus x minus 2. This does factor. And I could have picked probably an easier problem, and I apologize for that. 6x squared, negative 2. These two things are going to multiply to be the same as that. So multiply to be negative 12 and add to be negative 1. It means I've got a negative 4x and a 3x. I would have a 2x out here, a 3x. That would have to be a negative 2 and a positive 1. So my other factors are 3x minus 2 and 2x plus 1. 3x minus 2 and 2x plus 1. That means my solutions, I would have 2/3 and a negative 1/2. Now I can graph everything. And you could use your calculator to help you make sure your graph looks good. Negative 1 and a 2. This one is a fourth degree. So it's going to make a smiley face or make a parabola. It's going to start up here somewhere. It's going to do something like this. It's going to go up. It's going to come down. It's going to go up. Something like that. As long as I'm going through all the intercepts, I should. Now the retest is shorter, just to let you know. You still are going to want to know how to factor. You're going to need to know how to solve. And you're going to need to know how to graph.